Hey students, welcome back to my channel. Today we are going to do some more questions from the topic of diffusion. These are the past paper questions from paper 4. Let's do them and let's practice some more questions. Number 1. Concentrated ammonia solution gives off ammonia gas. Concentrated hydrochloric acid gives off hydrogen chloride gas. Ammonia, NH3, and hydrochloric acid, hydrogen chloride, HCl, are both colorless gases. Ammonia reacts with hydrogen chloride to make the white solid ammonium chloride. Apparatus is set up as shown. Now, as you can see, this is a glass tube, and in the glass tube, on one corner, there is a cotton wool dipped in hydrochloric acid, and in the other side, there is a cotton wool dipped in ammonia solution. So what will happen? As the question says, hydrochloric acid gives hydrogen chloride gas particles and ammonia solution gives ammonia particles, ammonia gas. They both of them start moving, and where the point where they both meet, they form a white solid ammonium chloride. They move because of diffusion. Now, after 10 minutes, a white solid forms in the tube where the gases meet. Write a chemical equation for the reaction of ammonia and hydrogen chloride. Now, the chemical equation is very easy. Ammonia is NH3 and hydrochloric acid is HCl. So, we'll write here NH3 plus HCl. They both will combine to form ammonium chloride. Ammonium is NH4 and chloride Cl. So this is the equation. Next question is name the process by which the ammonia and hydrogen chloride gases move in the tube. So the process is diffusion, because through the diffusion, the particles move from high to low concentration and both of them start moving towards each other. At which point A, B, C, or D does the white solid form? Explain why the white solid forms at that point. So, what do you think, guys? Where will the white solid form? A, B, C, or D? The white solid will form near to hydrochloric acid and away from ammonia solution. So, the white solid will form at A. Here, they both will meet. Now, explanation. Why is it so? Why the cloud is forming near hydrochloric acid? The reason is that hydrochloric acid particles have much higher molecular mass than ammonia particles. One molecule of hydrogen chloride gas, HCl, has the mass of 36.5. Hydrogen has atomic mass 1. Chlorine's atomic mass is 35.5, which makes the total 36.5 molecular mass of one molecule of hydrochloric acid. And as for the ammonia, which is NH3, nitrogen's atomic mass is 14 plus hydrogen atomic mass is 1, and we have 3 atoms of hydrogen, so 1 multiplied by 3, which makes it 14 plus 3, 17. So, as you can see, that hydrogen chloride mass is 36.5, which is much higher than the 17 mass of one ammonia particles. So, this means hydrogen particles will move slower and ammonia particles will move faster. They are lighter in mass. So they move faster. Hydrogen chloride particles move slowly, and they both meet at point A. So the cloud is forming near to hydrochloric acid because these particles are covering shorter distance in the given time. So the explanation will be because HCl particles are heavier than ammonia particles, hence move slowly or diffuse slowly. This is the reason. The experiment was repeated at a higher temperature. Predict how the results of the experiment would be different. Explain your answer. Now, at higher temperature, the rate of diffusion will be faster. As we know that diffusion is directly proportional to the temperature. If the temperature is more, diffusion will also be more. So it is happening, we are repeating the experiment at higher temperatures. The particles also move faster, diffusion will happen faster. So both, if HCl particles move faster, ammonia particles will also move faster. Both will meet at the same point. The point will not differ. They both will meet at point A, because hydrochloric acid particles, they move faster because of higher temperature, and so as ammonia particles, they also move faster. They both of them are moving faster, and they both meet again at point A. But now this time they will take less time because they're moving faster. So we will write here the result, the position of the product won't get affected. Won't be changed, won't be affected, but it appears quicker because the rate of diffusion increases. Or the speed of the particle increases at higher temperature. Now, as you can see that this question is of 3 marks. So the 3 marks of first mark is the position won't get affected. Still, it will be point A. Second mark is that it appears faster. It will take less time. You can also write that the product will take less time to appear. This time it will appear faster. And the third point is writing this, that at higher temperature, the rate of diffusion also increases. So this is the breakage of the marks. Then we have the next question. All gases diffuse. Choose from the list of formula the gas which diffuses the most quickly. Draw a circle around your answer. So which gas diffuses the most quickly? We have to see their molecular masses. For carbon monoxide, carbon is 12 and oxygen is 16, which makes it 28. Carbon monoxide, carbon is 12. Carbon has a mass of 12. These are the atomic masses, and you can see their atomic masses directly from the periodic table. Oxygen atomic mass is 16, and there are 2 oxygen atoms, so 16 into 2, which makes it 12 plus 32, 44. As for the methane, CH4, carbon is 12, and hydrogen is 1 into 4. 12 plus 4, 16. NO2, nitrogen is 14, and oxygen is 16 into 2, which makes it 14 into 32. So the total will be 46. For sulfur dioxide, SO2, sulfur is 32 and oxygen is 16 into 2. 32 plus 32 plus 32. So it is 64. Now you can see all of them. Carbon monoxide 28, carbon dioxide 44, methane 16, NO2, nitrogen dioxide 46, and sulfur dioxide 64. The question is which gas diffuses the most quickly? So the gas which diffuses the most quickly is the gas with the least mass. And the least mass here is of methane with 16 molecular mass. So we'll circle methane. Let's make a cloud around it. Explain your answer. Because it has the least mass. Methane has the least molecular mass. Next question. When chlorine gas Cl2 is put into a gas jar, it spreads out to fill the gas jar. When bromine gas Br2 is put into a gas jar, it also spreads out to fill the gas jar. The process takes longer for bromine as compared to chlorine. Okay, so if it is taking longer, so it might be that bromine has more mass than chlorine. What term describes the way the gas particles spread out? This is called diffusion. The particles spread because of diffusion. The main question is here. Use data from the periodic table to explain why bromine gas takes longer to fill a gas jar than chlorine gas. You have to use the data from the periodic table, and this question is of 2 marks. It's written that you have to give the reference of the periodic table. It means you have to mention the atomic masses and the molecular masses. Here, you can write that bromine Br2 has Mr or has a molecular mass. Bromine's atomic mass is 79.5 and we will multiply it with 2 because we have the bromine gas is Br2. So 79.5 multiplied by 2 is 159. Okay, so basically bromine has a mass of 159 or 160. Cl2 has Mr 35.5 multiplied by 2, which makes it 71. 35.5 into 2, 71. Okay, so you use the data from the table, okay, 160 and 71. So why bromine gas takes longer? Now you can conclude your answer that bromine has more mass than chlorine. So it moves slower. That's it. This is the answer. Very easy. Explain why increasing the temperature increases the rate at which the gas particles spread out. Why increasing the temperature increases the rate? See, rate is the movement, speed. Okay, rate actually means the speed, and speed is related to the movement of particles. It's the movement. So when we increase the temperature, the particles' movement increases and they spread faster. Why? Temperature directly affects the kinetic energy of the object. So when the kinetic energy increases, obviously the movement increases and so is the speed. So increasing the temperature, it increases the kinetic energy. It increases the kinetic energy and movement of the particles. So they diffuse faster. It's a 1-mark question, so this is enough. Question number 4. The apparatus shown was set up. It's a plastic trough. Then we have a solid silver nitrate on one side. We have a solid ammonium dichromate on the other side. The both particles are moving towards each other and the solid is forming over here. The product is forming at point X, which obviously you can see that it is near to ammonium dichromate and it is far from silver nitrate. Which means that ammonium dichromate particles move slower. After 5 minutes, a red solid appeared along the line marked S on the diagram. Explain why a red solid appeared along the line marked S. So why it is appearing here, what you can see from the diagram, that ammonium dichromate particles, they are heavier, so they will move slow as compared to silver nitrate particles. Silver nitrate particles are they are lighter in mass, so they are moving faster and covering long distance in the given time. So we'll write the answer here. The red solid is appearing near to ammonium dichromate, which means it has more molecular mass and its particles move slow or slower than solid silver nitrate. Silver nitrate particles move fast. So particles have less mass, move faster, and cover long distance in a given time. That's it. 3-mark question. This is enough to write for the 3-mark question. The experiment was repeated at a higher temperature. What effect, if any, would this have on the time taken for the red solid to appear? Now, they're not asking about the position as they asked in the previous question about the position. The position will remain the same. The S will form over here. It will remain same. Okay, the S position will not be changed. But now, because we are increasing the temperature, the particles will move faster. So the red solid will take less time to appear. It will appear quickly because the particles are moving faster. So we'll write the time taken for red solid to appear will be less because at high temperature, rate of diffusion also increases. Rate of diffusion also increases. Full stop. So that's it. These are some of the questions related to diffusion topic, and these type of questions can come in paper 4. So you must know how to solve these questions. What should you write? And I hope you get it. And I will make more videos like this. So please like it, subscribe to my channel, comment on which topic you want me to make the next video, and which topical questions you want to do, which are harder for you. So I'll make a video on that definitely. So I'll see you next time in the next video. Bye.